Test, test, test. Let's go. So yesterday, I made this blur effect. I'm going to continue with the graphics today. Particularly, I want to distort these panels with a transform matrix. So we'll see how far we get with that. First thing I want to do is take out some things I don't think we need to do with the blur that we did yesterday. So common, we have this thing called disk blur offsets, and I don't think we actually use that. So I'm going to take them out. And the disk blur now doesn't need to do make offsets. There's no such thing anymore. Get rid of that note, which is good. It doesn't actually need, it does need the canvas, doesn't need the camera though, which is good. Alright. Alright, cool. Let's check that this hasn't broken it. It has. Okay, what's gone on there then? Why is that broken it? We need to take it out of the static buffer, maybe. No, I don't think so. Why is that broken it then? Blur is on. I'll rebuild, and then if that doesn't work, I'll fix that. I wonder if the shaders didn't actually build either. We have to rebuild all the shaders. I'll rebuild the shaders. Oh, that was so wrong now. That's processor. Processing. What did I do, man? Make it so bright. Alright, let's have a quick look then. Let's put this here. And then so what is I gonna get to? 2 times, it's gonna get to 16. It's 34 of them all together. So this is only using XY as well in the blur comps. Which is weird. So this is, so R is 8, 16. So that's going to go from so the maximum that's going to be is 16. So that's going to be 16. So we can go, this is strange, so we can go R is 16, do that. Oh no, we need R there as well. So 16, 32, 33, there's 34 of them all together. I wonder if they're meant to be ZW as well. Oh, that's a crazy effect. I don't know why it's so bright. definitely looks worse for some reason. Alright, let's go back. Figure out what caused that. And it's interesting we're only using the XY values of blur comps, even though we are storing stuff in Z and W. So we're storing stuff in Z and W as well. Only using the X and Y, I believe we are. Post-processing, post-processor. Yeah, we're storing these. XYZW, XYZW. Blur params. So it's between 0 and make some kind of ratio calculation. We don't even use these. If I was to just get rid of them, well, not that. Put 0 in. I'll put 0 in here. Literally the same effect. Okay. This thing called complex blur here as well. Doesn't actually ever seem to be used. That's what I wanted to delete. Need to get the paper back up. have a look then. So low quality filter, high quality filter. Let's have a quick look at what I'm using. Different filter parameters. What's this called? There's lots of pretty pictures. There's the actual stuff. I wonder if... Talking about masking. We have a shader toy example. I want to know what it is doing. This is a very much simpler algorithm, isn't it? Here we go. So that's doing mult complex. All right, okay. X, Y, Z, W. So let's just pull this off, minimize that, and then mess about with this. So let's go up here. That seems kind of right, except I wonder why we're not using the ZW component. Oh, hang on a second. No, this is going, so that's like the pitch. So it's going to this, it's going the kernel. The kernel width is 16. So it's going to the next row down and then plus in 1. X, Y. So it is actually, no, it's not using. We could probably just reduce the total, the amount of blur comps we need to upload. That's what I'm thinking. So what it's doing is going and then across one, then doing X, Y from there. Okay, let's have a go at that then. So actually, this is 136/2. $68. This is only actually 68 floats. This is disappears. This is also 68 floats. And then in the this is 68 float 2s. Which depends on the actual packing of this, actually. Maybe that's why it's packed. No, hang on, I've done that wrong. It's 34 float 2s. Rebuild these shaders. And then here just like this. Depends on packing. Must be a packing thing. That. So let's fix that and see what that buffer looks like. So the vert. What's going on here? Okay, so we've got them weights now. So I zero. Blur comps 0. What is R? R is 8, so that's 17. Blur comp 17. Yeah, so we've got the real and the imaginary part. P and Q. Which I think that lines up with where we're doing it. Where was it? It's actually in the post processor. Make blur params. real and the imaginary part there. C23 is coming out a lot of naught noughts. So it's I in this case. 5. So 5 plus 5 plus 17 is 23. And it says XY as well. Let's just check that we're actually doing the right shader here. So 5 plus 20, 5 plus 17, 20, 22. So blur comp 22. 1, 2, oh, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 20, 1, 2. So it's 0.04. Yeah, blur comp 22 is written right there. 0.04, 0.01. 2, 3 has come out as 0, 0. There. 5 plus 8 plus 8 plus 1. Oh, I'm tired today. 5 plus 8 plus 8 plus 1 is 22. So blur comp's 22. So it is must be a padding thing. That's a padding thing. Look here. So it's come out as 0, 0 because it's padded 2 zeros in. That's what's happened. Okay, so they have to kind of be packed into float 4, which means this has got to change a bit. Oops. This float 4. 17 float 4s. How do we get it then? There. I think it kind of knows that it's going out of. Getting a weird error there. So. Ooh, that changes the I value as well. Alright, you know what I'm going to do? I'm just going to keep it the same. Because it's working. And it's only a tiny little optimization. So first, we need to take these disk blur offsets out without messing up the shader. So first things first, let's just go to post processor and set these to 0. Just false. 0, 0, 0, 0. Right. Fu Manchu, good morning. Hope you're alright today. Just working. Well, I'll finish this blur now. So, put the menu on, you get this blur up here. So now I'm going to work on distorting this so you can like warp it around today. That's the plan. Hope you're okay there. So that does come out at 0. So we're going to take the blur offsets out because I don't think we need them. Are you back? Are you on the game? Back? Are you working on the game or back to the engine? Working on the game. So I'm doing the UI for the game. Yeah, that's what I'm doing at the moment. But yeah, valid question. Back on the game now. I'm going to be back on the game for maybe 6 months. But it's graphics programming, which is good, which is nice. First graphics programming, then vertical slice after that. So I'll be making out, like building out an entire region of the game world and all the gameplay and everything to kind of, not finished, but so it could be a demo, for instance. So maybe in a year's time I'll have a demo, which would be good. That, right. So the static buffer now needs these offsets taken off it, and these offsets taken off it. So are they all in 4s? Need to keep them in 4s. They're in 2s. So float, 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 uint. So we need float pad 2. That will work. You're building an RPG MMO with fully destructible terrain and infinite gameplay. Oh yeah, imagine that. This is the moment-to-moment gameplay, right? You're on the spaceship, running around, talking to NPCs, getting little notifications because your plants need tending or something. You know, you need to pick the fruit or something. Quest log. So there's all these quests to do. And the quests just take you around the game world. That's basically it. It's like the dream of every indie wannabe, yeah. So the gameplay is going to be simple-ish. Simple. Light, casual. And the gameplay, like, you know, it's kind of... So all the gameplay systems are in. They're already written. Wrote them at the beginning of the year. What they need is content now. They need artwork, quests, characters. But the systems are in. You can grow a tree. Only joking, yeah. Oh yeah, I know. No, I know what you mean. Yeah, gameplay's like in kind of. It obviously needs to be like fleshed out. But it's in. I don't think I would attempt anything like an MMO. There will be some RPG elements. RPG, I think, as long as you make it light enough, it could get very, very complicated. Yeah, okay. Have a good couple of hours, and then hope the meeting's all right. So now that's made that disappear. Interesting. We've put the padding in. Let's just rebuild the shaders. Shaders might not rebuild if... Yeah, did he not rebuild if... Change his header file. Yeah, that's probably it. We need to fix that. Okay, so they're still not there. So why does changing that... So we've got... Yeah. So 136 has to go into 4. Exactly. 34 times. 4 definitely goes into 4. I might not have these static arrays. I'm assuming you can do this, and this is totally fine. So the take something out of the static buffer, it breaks it, essentially. I'm not entirely sure why. We'll say float to pad. Does it need padding? It should have sell 16 byte boundaries, low photo register boundaries. Right. So that aligner 16 actually refers. So is this like a float 4? In which case there's no pad there. Yeah, that's brought it back. In which case there's no pad there. I'm definitely using these though. Needs that padding there. To familiarize myself with graphics again. So the pad's automatically put in. I think that's what it is. So what I need to do is align as 16. Is that allowed? That should work. If that's allowed, that should work. Just to get it onto the next boundary. So we need the manual padding there to align it. It's work. Common. So that works. It's not compiling the shaders properly. Alright, let's just rebuild all the shaders. Rebuild, rebuild, rebuild. Okay, that works. Question is, if I put that manual pad in there. So what it's doing is it is padding 2 zeros here. If I do it myself, I must be float. That doesn't work. If I do float, pad 0, pad 1, that works. It's to do with the arrays. So if I do float 2, add. That works. That's what I want. That's what I'm after. Right. That's good. That's all I wanted to do. GPU padding. I'll get so good at this in a year's time when I've finished the graphics for the game. Right, there we go. So now we can move on. So I'm going to do distorting the menu. So moving the menu around in 3D space essentially. First thing I want to do is go to Game UI, and wherever we're building the canvas for the menu, wherever we made the canvas, menu canvas. So all I'm going to do, so we're in a tick menu. I'm just going to go for a second, menu canvas, post processing effects, grayscale, and just see if this works for the game menus as well. See what this looks like. Because I'm going to do it via the post processing pipeline, I think. Okay, so that hasn't worked. It's not actually doing the grayscale processing effect. So we need to do it later. So let's just do it on, in theory we can just do it on the, if we go to game menus, pause menu, tick, we'll just do it here. We can just go Canvas, add post-processing effect, grayscale. I'll just apply it to the pause menu. Hopefully. Just want a black and white pause menu. There we go. Not the transition. The menu itself is black and white. Transition's going to be handled differently anyway. So this is using the post-processing pipeline now. So we're going to make it another one, another post-process called struct what do you want to call it? So I might actually rename these, give them a post-process. A little tag on the end. Boom and chew. Bloody hate size T. And to enable all warnings, obviously in my code, I tend to use int a lot. And then every time I need to enter STLC, it's just typecast a lot. Oh, yeah. I hate the underscore T bit. But yeah, I know what you mean. I'm going to implement today, hopefully, the beginnings of, you know, that Death Stranding UI distortion effect. The beginnings of that today. So it's real game work. It's not gameplay, but it is look and feel, which is just got to build all that as well. So I added front-end post-processor onto the graphics renderer yesterday, so now I can post-process everything, including game menus. So I'll apply a little post-processing effect, the grayscale post-process, to the pause menu. So it makes the pause menu black and white. So I'm going to do it through post-processing this distortion. I think that's the idea. So it's going to be struct apply transform post-process. And that is just going to have a matrix in it. Matrix, what's the this is how little I deal with matrices. I don't even can remember what the type was. Transform. Oh yeah, look at that blur. Yeah, it's good. It's a nice blur. It's an old effect that I had. It's much nicer than like Gaussian blur. It's particularly good on like bright points in the level. I'll turn it on and I'll describe to you what I mean. Take off my glasses. Yeah, different blur though. This is it because I need glasses as well. I should wear them, but I never do because I'm always staring at a computer screen. This is a camera lens blur. So it's not a smudge blur like but it looks different to the blur that I experience in my eyes. This is like a cinematic film blur. Don't know. Maybe you experience this type of blur. You know, in GTA, where if you're standing on the hill and you look in the distance and all the brake lights are bloomed out in circles, it's that type of blur. You can use it for really nice depth of field. Yeah, exactly. Yeah, it's a disc blur, so Gaussian blur smudges it, so it just basically like smears the colours. Well, what does it do? It pulls colours in the Gaussian blur from around it. That's how it blurs it. Whereas this pushes circles out. So every pixel, it pushes a circle out. And the algorithm's good because it's separable, so you just do like horizontally. So you push them all out that way, and then you push them all out that way, and it makes a disc, which is quite it's quite photorealistic, really. So I don't know if I'll use it for the pause menu. I'm definitely going to use it in the menus. It's either going to be the full screen or it's going to actually be just behind the menu. I'm not sure yet. Doing that with shaders. Yeah, shaders. Yeah, pretty much. You set up some stuff on the CPU, upload that to, so you need a lot of coefficients. I think you need about 40 numbers. You upload 40 numbers to the GPU, and then it combines them all together. Yeah. But if you were to do this non-separably, so brute force, it would be really slow doing this. But because it's separate, it's from the Frostbite engine. That's where I got it from initially. So it's, you know, if you look at FIFA, look at the crowds in FIFA, it's the same blur algorithm, or it was then. It might have changed it now. Yeah. That's it. Blur this really nicely, please. But I also built the front end of the post-processor yesterday. It was a productive day, so I can post-process even the game menus. So this has got a grayscale post-process on it. So I could probably apply the radial blur to the menu and try that, see if that actually works. Disc blur. I think actually disc blur needs to be, the blur amount needs to be defaulted to 1 as well. Let's see if we can actually blur the menu. Do that cinematic blur thingamajiggy, yeah. Yeah, as you get through your game that you're going to make, you'll learn some good graphics algorithms. It is a fun area of coding, graphics. Especially if you want to do some like physically based rendering stuff, which you can do in more easily in 3D. Just see if I can blur the menu then. No, it doesn't work. Just a black box. Should be able to. I wonder why it didn't work. You'll have to, yeah. I mean, depends how far you want to take it. You just need lighting, really. Lighting and shadow. Well, So you're doing 3. Well, so what would you need? Lighting. You need a lighting algorithm. Shadow. You probably want some kind of sky rendering algorithm if you're going to be outside. And some water. Probably some water rendering algorithm. Probably all you really need. Let's have a quick look at why that isn't actually working. That's probably a very good reason. I don't know. And then if you want to do some post-processing, like some bloom, do a bloom shader. So the menu canvas, post-process. So that just doesn't work. This just doesn't work. This disk blur thing. Should work though. This is fixed. We've spotted a good bug. Oh, there's no static buffer on it. That's why. So how do I apply the static buffer to a canvas? It is by. So the renderer has in it some buffers that go to the GPU. What I want to know is how we add one to a canvas. Build global buffers. So we have to do build global buffers for the canvas. So if I do get renderer, build global buffers canvas. So I might make this automatically happen for every canvas. Check that he's actually doing what I'm thinking he's doing. Yeah, so probably might need to go after. All I want to be able to do is just do add post-processing effect and it will work. So it should have the global buffers now. Make all the blur parameters. Question is, how does this disk blur? We have to call tick on it. So we have to call tick on it as well. I think that's what it is. On this disk blur. So unfortunately I need to copy it in. So you need to go disk blur, blur. And then you have to go blur.tick. And then you've got to pass it in. Now that's not how I want that to work really. Tick takes the canvas. There we go. So it looks terrible. I don't think it is blurring it. This blur amount is 0. Okay. So we need 2 ticks. Really. We need like void apply or something. Need something like that. And then the post processor needs apply rather than tick. So we do this, and this is called apply. It goes apply. This is apply, not tick. And then apply for this does the upload. Like that. Canvas end post processor apply now. And then in game menus now, this is just that. We do need to build global buffers as well. There we go. Now it's doing the bloom. Now it's doing the blur. Looks god awful. But it's doing the blur on the menu. Alright, so we need to get rid of this build global buffers thing as well. So where does this get called? Get bug content draw, build global buffers. Yeah, I don't know. I think all we do. So does Game UI Canvas have? So what does build global buffers do exactly? Build global buffers registers it to have. So to be fair, it could probably go in Canvas. Could do this. Before any applies happen. If it has post-processing on it. I'm going to need to have a break and blow my nose because, oh my god. Okay. So build global buffers is not necessarily... This might get called twice a frame for some canvases now. So all it really needs... Wow, what does it say? Some post-processing might need... Yeah, it does need stuff like this. We're going to leave it like that for now. Oh my god, yeah. So the build global buffers for game. I think, to be fair, that can just go away. The game HUD. Game HUD still needs it. There we go, got the blur applied to the menu. Little circles there. But I don't want to actually apply that. I want to apply the apply transform post processing effect, which will eventually take a matrix. But we'll let it be the identity matrix for now. And then DX12 post processor. We need to make one of these for disk glow post process. We need to make one of these for the apply transform post process. So my Visual Assist can't handle that. We should. If we just return source, it means we're not applying anything. It should still work. Fix these bugs, these compiler errors. Disk blur post process. That's probably just... Is that for it? Just didn't get changed. Disk blur referencing game UI. Somewhere. Right. So hoping we still see the menu. If we do. But it is going through this pipeline now. So it's coming into here, and we have a little spot here now to apply this transform post process. Now I've got to work out how to do it, which I don't really know yet. We have a matrix. I know we need a matrix because we need to transform some stuff, but we'll get there. We'll get there. I'm going to have a 2-minute break and I'm going to run some ads for 30 seconds. But I'm going to have a 2-minute break and make a cup of tea. Back in 2 minutes. Okie dokes. Let's have a look. All right, cool. I've just turned it on today so I can have more control over when ads show. Just still working it all out, really. So if I disable automatically scheduling ads, it makes pre-roll ads for incoming viewers mandatory, which I don't want really. Okay, cool. Anyway, we have a little spot here now. So what do we want to do? We want to draw 4 vertices somewhere. That's what I do know. I mean, we could, it's only 4 vertices, so we could just transform them right here rather than doing it on the GPU. Seems a bit crazy to upload a matrix to a GPU to then just only apply it to 4 vertices. So have a look at the vertex shader for the post-processing. Doesn't actually take any vertex positions. Oh, I know what we could do. We could attach 4 float 2s to the root context and then call a vertex shader 4 times. That's what we could do. And then just work out the positions of that vertex. So what would we need? We'd need X, Y, U, V. So we need 4 vec4s. So do they have to stay alive? Who knows? So we'll do -1, -1, 0, 0. So that's the bottom left corner. Do -1, +1, 0, 0, 0, 1. That's the top left corner. +1, +1, 1, 1. The top right corner. +1, -1, 1, 0. And then we do PP bind root constants. Index 0. There's 16 of them, so I'm going to make this float just 16 floats. 16 pointer is X, Y, U, V. Block offset is 0. So we'll just bind some root constants. These will get transformed by the matrix. Excuse me. Maybe we do make them vectors. So this is a array count XYUV times size of. This is just size of XYUV. This is XYUV. XYUV 0E. That's the pointer. Offset 0. We need to do more than that. We need to then. So we need a shader. So the post processing. So we need a new vertex shader. VS main with verts. VS main with verts. I'll call this. I'm just going to keep it the same for now. Entry point target. VS main with verts. VS 6 0. So here's a problem. The root signature is attached to the pixel shader. Which is a shame. Which means we need another pixel shader which has got blit on it. So blit with verts. Blit with verts. PS 60. And then we need another root signature. So the blit one, it's the same as the blit one. Blit with verts. Except it's got root constants. Need to find some other one with root constants. Here we go. Root constants. B0 visibility vertex number of 16. And then we need the constant buffer. There it is. For that, which is vertices, and it's float one. Vertices CB, and it's float for verts for. Right. So we have to bind that to 2, flush to descriptor table 2. I don't really know. DirectX will tell us anyway. So we need some pipeline state. Let's check that shader builds actually. Yeah. So I'm going to put this over here just to reference. we need pipelines for these. I'm just put the comments just so I can find it. Post processing. It's the same as Blit. It's just Blit with verts. And it's VS main with verts. And it's Blit with verts. Right. So let's just not do anything yet. Just check this runs with the new pipeline in it. Seems fine. So we're gonna go copy the grayscale one. This is Blit with verts, and we also need to bind these root constants. I'm just going to run through this and see what happens. See what the bind root constants does. That might be straightforward, except it's not correct. Descriptor table. So it goes like this, I think, and that is 1. Random magic numbers of graphics programming. No, we didn't like that. Currently, so number value is 16. 64. That's come up as 64. Oh, right, no, it's just 16. It's I'm just gonna put 16. I know it's 16. It's not the number of bytes, it's actually the number of numbers. Okay, that was alright. So this should in theory look the same. We're running through a new shader. What I actually need is a little always on top. Windows 11, make window always on top. Power toys. Power toys. Always on top. Yes, that's what. So I want a power toy. You need to get one. You need all of them. Good. So we're in a new shader. So I can test that out. Blit with verts. I can just return 1. There we go. We have these verts as well. So position is verts ID, I think. Let's break everything. verts id.xy. Oh, it worked. UV. And that's the UV. What? Okay, no. Position. This is verts id.xy. Okay, they're backwards. Look, it's distorted though. And this is verts id.zw. Right then. So now we just need to get these the right way around. Let this install PowerToys second. I think it's going to be handling for working with shaders if I could just keep this window always on top. Always on top. So you can do Windows Control T. That didn't work. Windows Control T. It didn't work. Maybe we need to reopen the window. It's not working, man. Does it work for another window? Nope. Okay, it's not working. Do we need to actually... Do not activate when game mode is on. So I do want to activate it if game mode is on. Doesn't work, man. Doesn't work. Why didn't it work? Okay. There we go. Now it's working. Smashing. Okay. So now I can just change stuff. This is awesome. So that is obviously wrong. So shade is right. Let's just move some of these around. So they're crossed over. Yeah. So it's going bottom left. Oh, it's a triangle strip, this. Thing. So that's bottom left, top left. So it's like this. Not actually changing anything, is it? How many vertices is it actually drawing? 4 vertices. Okay, well, let's do this. 2 vertices in the same place, so we can see triangles. Okay. So one, two, there's 5 there. Hang on a second. So bottom left, top right, bottom right. So I think we'll start by swapping all these around. So this is, we'll try that. That's top left, that's top right. Maybe it has to go in a Z. Let's try doing it in a Z. So it's that, and that one, and then that one, and that one. I believe it's a triangle strip. Let's just have a quick look. Triangle strip vertex layout. So it goes in, alright, so it goes in a kind of an N shape. So that one, then that one, then that one, then that one. That's right, I think. It's just the texture coordinates that are wrong. So 0, 0, 1, 0. So I just want to fix the actual mesh of that. Okay, so it just picks the mesh. Menu canvas post-process. So it's this wireframe. That seems legit. That's a proper mesh. That's exactly what we want. So 0, 0. So it's going, and then it's going up to the top, and then it's going down. Nope. Right, that's it. It's just upside down. Just flipped. So ones become zeros, zeros become ones. It's only flipped in Y though. Okay, that's right. Oh, that's completely wrong. See that? Yeah. So we need to flip the Y around. So 1, 0, 1, 0. Awesome, there we go. So now we can apply. So we could do something like could maybe like put 0.7 on the Y. That should distort it. Yeah, there we go. So we'll do 0.9 or 0.8. The bottom right corner is 0.8 on the Y, and then we want the top. No, that's the top right corner is 0.8. The top left corner. No, the top. That's top right corner. The bottom right corner, which is this one, we'll say is minus 0.8. Right. Wow, that's so bad. Okay, so it would actually be top left corner that has to come round down. That has to be like 0.9. That's one. That goes up to 0.9. Yeah. And then this one goes up to 0.9 as well. Not that one. This one is minus 0.9. Right. And then let's go to the post-processing. And then what we want is this sampler. Say it to be linear for a sec. So there's no linear sampling on there. Down there. For some reason. So let's just pick and see what's going on. We need to wrap. Do wrap. What is it? Not wrap. I don't know what it's called now. Sampler. Right, so it's the texture coordinates we need to distort. That's why. So let's have a quick look at that. So I have to make a note of what these are. So that is bottom left, bottom left, top left, bottom right, top right. We want the top left Y to be like 0.1f. And then we want the bottom right Y or V to be 0.9. Top left it put it up. Maybe that's not correct in UV space. Hang on. Let's just have a look at the texture coordinates. Just return input uv.xy. Right, so we could do it here. We could say if id equals 0, result.uv.y minus equals 0.1. We'll keep 2 like that. We might need an actual separate like unit variable. So it's like it's you can see there's like a seam kind of. Oh no, something weird going on there.
This is the sound that the gods will play to part the clouds. Live rounds on the guards are strip man down. These vibes for the night while the high is right. Take flight, lean sideways. We master the sky, groovy. We Bobby Bird, James Brown and Bootsy Collins Phil. Feel it in the air, that real. Feel it in the field, feel it in the air, that's real. Feel it in the field, feel it in these frills. You got the chill. Like they're bringing anything to the table. Bro, I'm not your son, see I'm able. I do my own bits. Limited dissonance and missing classic shit. I know that you're feeling it. blunt rolls and a black pouch. Roaming back streets around south. All my boys, we hit that loud. Feel the vibe when they blast out. Now let me show you exactly what we all about. Let me get, I'm on the sound, hoodie season, back around. No more summer bounce, let you squeeze out. Keep that indoors when we're throwing down. Oversized jumper with our underwear out. I'm on the sound, hoodie season, back around. No more summer bounce, let you squeeze out. Keep that indoors when we're throwing down. Oversized jumper with our underwear out. I'm on the sound, hoodie season, back around. No more summer bounce, let you squeeze out. Keep that indoors when we're throwing down. Oversized jumper with our underwear out. I'm on the sound, hoodie season, back around. No more summer bounce, let you squeeze out. Keep that indoors when we're throwing down. Oversized jumper with our underwear out.
Figure out what's going on there. So if we put that to 0.5, it goes all the way up there. Plan. You can kind of get away with it up to there, really. Okay. So I need to include this matrix, really. We could pass the matrix in. I'm not sure. So, if we do 0.5 times that, nothing happens. 0 times that. Right, so that scales it. So what I think we do is we just try and rotate. We'll just try and rotate it. We'll leave it like this. So how do you build a rotation matrix? So we want a rotation matrix about y. Y rotation matrix. So y rotation matrix. And then we'll just say T. T is not identified. So let's just temporarily include the BM engine app, then we can get T. So we'll just do this. The M is that, and then we're just going to go go auto v0 spec 4 this 0 this times M. The XY value of that. This, and then this, and then this. And that's V1, V2, V3. And then I'm just going to just substitute them back in. So that could just be like that, really. See what that looks like. All right. If you want to rotate it in what is it? Pitch. That's the X rotation matrix. Times Y. Y is on half the speed. T. That's what this looks like. I think we're actually getting somewhere now. So we're completely transforming the menu. And we'll just scale it as times scale matrix. 0.1 times t. It's nearly coffee time. That deserves a celebration. That's so mad, isn't it? Whoa! It's getting bigger and bigger and bigger. We've got to actually... That's just making a scale matrix. It's not actually... it's not actually a repeating function, is it? So this is... scaling's not... These are repeating functions, but the scale matrix is not. So we need to do bm sine 0.5 times bm sine f. That, and then if it puts a half onto it, that should make it a repeating function. So it doesn't just get bigger forever. It should slowly get to like the biggest size. And then back off again. So it should start to kind of back off now. Okay, so I'm going to have a 2-minute break, make a cup of coffee. So what we need is some real good values for the rotation and the scale. Because I want it to just like, put the mouse over it and it should go like come alive a little bit. And then when you bring the mouse back over again, it just settles back down to normal. Not like it needs to come alive, it needs to be very kind of... Because obviously if it needs to be subtle kind of, because if we're moving the button rendering, the hitboxes stay the same. These hitboxes are still the same. So it needs to be really kind of like, not move out of the hitbox of the button essentially. So we need to like back the scale off a bit and then do it. But we'll see, we'll get there. So yeah, I'm gonna have a 2-minute break and then we'll do that. Coffee time, run an ad as well. Little ad break. Right. Here's what's mental. Could do this for the game. Could do this for the game. The game canvas as well. Just a test. So Game level. I'm actually drawing a game level. Let's do canvas, apply post-processing effect. What's it called? Transform. I don't know what the effect was called. It was called apply transform. We apply transform post process and then see what happens to the game window. Look at that, oh my god. That's so bizarre, isn't it? So bizarre, man. It's getting really small. It's going to 0. No, it's coming back again. Post-processing's fun. Fu Manchu, have a good meeting. I've done something mental with the renderer, look at that. It's spinning in 3D, the whole game. Yeah, isn't it weird? It's like it's on a plane, spinning in 3D. See you in a bit. See you in a bit. Alright, that's enough fun. Back to the hard work now. So, so if we go back to game menus, we're doing this. We can actually put in a transform. So that's probably going to be this transform. And this is the effect transform. Apply transform post processor. I've spelled transform wrong. Transform. Okay. So the transform is this. Oh man, formatting here is this. So it's T. So it's an X rotation matrix times a Y rotation times a scale matrix. And then really these are just zeroed out. So this can be left alone now. If it works, it can be left alone if it works. Yeah, there we go. So now this transform is actually coming from the menu. So we're back in game land now. Okay. So what I need to do is find good, nice values of these. That look good. And I need to do it in such a way that I can just look at it. I have to rebuild the game all the time. How am I going to do that? Could do it via the console. Something like that. Or I could just put another little menu up here with them in. How easy would that be to do? Menu canvas. We need a new canvas then. So we could do it in a sub. We could do it in a sub menu. That's what we could do. So we'll do it in sub menu. We'll do it in the, I don't know, the game save menu or something. So game save, what's it called? Save game menu on tick. This is kind of temporary, so it's temporary code. We're just going to go canvas, draw, text box, xrot, static float, xrot 0, xrot. Title, initial value, delta. Around. There it is. We need to go actually. I can't see display. There we go. Probably need to go to HD for this because there we go. Xrot. There we go. So we can change the X rotation value. Xrot, Yrot, scale rot. Scale rot, just scale. scale. Actually, these we'll just put right at the top in temp. So on the draw pause menu now, pause menu tick. This is XROT, IROT, and scale. Scale actually needs. Oh, what's going on there? I'm supposed to half to it. Scale actually needs to be defaulted to 1. So now we can pick some values that look good. So if we just scale it back a bit, something like 0.8 or 0.9. So don't click the menu. So here's the thing, it's also not anti-aliasing the border. Do want it to do. So if we rotate the texture indices, or we could just anti-alias it. We could make an anti-aliasing algorithm. These default deltas are too big. So we're getting aliasing now because we're actually rotating geometry. Needs to be like super subtle, really. So let's try let's go back to this. Oh no, hang on. Let's Go back to the DX12 version. Do this. And then let's set it to be the texture coordinates that we move. Feeling this will look distorted. And that needs to be between 0 and 1, really. Okay. Feels like scale is too big. Ah. Take out scale. Let's move it right back to the most basic one. So we're just going around X, which means pitch. Yeah. So maybe do this and let that be the texture coordinates. So what it really means is that zeros have to be -1. Oops. Just experimenting here, really. All times. Or we do just anti-alias it. We can do that. Whoa, look at that. Let me nick. Okay. This is the effect. Transform. So now I can just the only problem is the anti-aliasing. All right, let's pix that and just have a look at the geometry. Daughter, how's it going? It's snowed, oh man. I figure out how the snowblower works, yeah. It snowed here a couple of weeks ago actually as well. Never really snows much in England. So I'm working on transforming the menus. So I've got this little setup here. I'm working on the game UI. So it's going to be it's going to be small, and then when you go over it, the transform will probably reset. But like it'll look nice. It'll like go and then it'll go relax again when you take the mouse away from it. That's the idea. If I can get it to look good. Red's not the final colour, no. It's gonna feel like very sci-fi, kind of Star Trek. You know, like the Star Trek consoles or something, or I don't know. I'm gonna see how it goes. What I do know is I want the menus to not just be like static menus. When you put the mouse over them, I want them to like stand to attention, if you know what I mean. And then relax again. So we'll see how that goes. But yeah, I've got to fix this aliasing down here first. Of which there are various things we can do. Put in this blur as well. Yesterday, working on UI for the next month or two, really. Messing with authentication. Ah, cool. Just have to read many. Yeah. Oh, nice. Fix that. Pretty sure there are more than 10 RFCs, you mean? So it's because we're drawing geometry now. That's why it's aliasing. So I could draw it to something like a multi-sample buffer. A multi-sample texture target. I knew we'd have to do some anti-aliasing coding, you know. It means going into another project and looking at something like temporal anti-aliasing. Could do that. Could just anti-alias this. Okay, decision made. That's what we're gonna do. Right, so we need to make a note of these transforms as well. So we're gonna scale it down a bit. Rotate it in X a bit. So something like this. Something like the anti-aliasing is really bad. Like that. So 0.23 minus 0.29, 0.96. Not 0.23. Minus 0.29, 0.96. so that should automatically be that translation now, or that transform. Okay, cool. So, temporal anti-aliasing, just for this thing. What I want to know is as well, I bet this is probably being, yeah, so there's a big black border there as well, which you need to get rid of, which we can. That's just a blending operation, that. Temporal anti-aliasing, I do remember it being straightforward. Need another project. Awesome. Awesome. Didn't work. It's already there. That's good then. And does this build? Does this build and does this run? It would be lovely if it did. What's this? This is just releasing keys array. What's the problem here? Oh. CRT secure no warnings. Oh really? Blimey neck. That's pretty, keeps you on your toes. Right. The executable, build that. So this doesn't like this. Hash table error, syntax error, unexpected token. It doesn't know what keys array is. Oh, it's just keys. It's just keys. And values. On AWS, you've got a bloody problem. It's a misnamed variable. Yeah. This is an old project, this, so I don't really know where. Oh, this is not very song. Alright. Stop. We'll go for this. Ban this bot. Do you work on corporate at all? Under the wrath of Jira. Wonder if our tickets should be 1-to-1 with pull requests. I don't know. I don't work in tech at all. No. I do use Trello, which is Jira, similar like Jira Lite, I suppose. But no. Reheat region operator equals. What's he trying to compare here? So we need an operator, we need free heap region. May as well just for the size. Don't understand what he's asking me. So what is P data? Free heap region. Get more points. Okay, yeah. Agile folks think they're important. It's not the pointer, it's the... I think it just wants to know if it can compare. Free heat overload has similar conversions. It's not that. Could be that. Could be that. Don't understand why that's there. So we need to include string stream. Bit in stream. Cannot third party. I need to build third party. Oh, she's got a load of stuff in it. Right, scrap this because I'm not trying to go through. Oh, what is it? Is it just? It's just OG. Cannot find OG directories. There really. Third party. Og Vorbis. So it is there. Oh, look, it's got Ben hard-coded. No, that's not how you do it. I think it's solution. And what is this? Solution dir. That's what you want. Awesome. Okay. Assets. Operating system has not been defined. On Windows. Assets.exe. So what's the problem with this? Rebuild. Okay, that's probably another hard-coded path somewhere. X64 EXE, so it's looking for third party that. It's looking for the wrong. Have to build a release build. Cannot find third party.lib. Build. So this again. It's the wrong directory. Whoops. It's solution directory. There and there. That built. Alright, does it run? Does it crash? Nobody knows. Might launch in the wrong window, this. Wow, computer's stressing out. Whoa, this is a different type of thing. This is another project that I wasn't expecting. This is a like a candle chart. Whoa, mental. Literally no idea about that. Let's have anti-aliasing stuff in it. So TXA does have anti-aliasing stuff in it. Okay, let's look at the history. So I haven't worked on this since 2022. So let's go back to here. Probably suffers from all the same problems. Okay, so we need to include string stream, S stream again. EKG. This project has lots of anti-aliasing in it, so it'd be good to get this running. Okay, so this just doesn't work. Compile shaders. Debug. DX load shaders doesn't work. So this is game model PBRPS. This is this one. Apparently. Compile shaders release. Let's try release build. Nope. Let's just unload assets, data. Just delete both of those. Rebuild all the data. Nope, doesn't work. Okay, well I could go back to an even earlier point in time. I don't know. Here. This is so weird how it's ever got compiled before. I think I've got Argon 3 from DXtract to DX render target. Movie Night Productions. I have no idea. It's royalty free, so anything could happen. Hope you're alright. I'm just looking at an old project. Yeah, it's jazz. It's art. You know what, I think I'm going to have to. I don't know what DXtract is. Surely they should be render targets. No idea though. No. Alright. I'm gonna have to accept I can't get this to work. So I don't want to spend too much time on it. And we're just gonna read it. Read the code and try and understand what's going on, rather than step through the code. Oops. Can't pick a testing pitch, yeah. So this is an old project that has anti-aliasing stuff in it, because I'm going to do some anti-aliasing. I'm doing game menus, really. And they're going to move around in 3D space, which probably means they're going to... Right. Nope. Swap back to the actual engine. Nope. Show you. So, you see how this is like skewed a bit, and then there's this aliasing down there that I'm going to try and get rid of. And then when you like go over the menu, the transforms reset to normal. Whoops. Broken it, mate. But I'm just gonna have a go at getting rid of this aliasing. So we need some. I'm just gonna do like some temporal anti-aliasing. Put that in. TXAA. Come on, Visual Studio, you can do it. Shaders. TXAA resolve. TXAA. Okay. Enable TXAA. So let's just follow that through. Jitters. Halton. That rings a bell. Halton. For Halton, generate Halton 2x3 sequence. Okay, cool. So we're going to put this in. So go to the post processor. Other post processor. And we're going to have struct. We could do it in the actual transform. We'll make it in here. FXAA post process. And we need an array, by the looks of it, of something called vec2s, an array of vec2s. Movie Night, thanks for the follow. Got any questions, just ask. No problem, no problem. If you want to talk about coding or whatever. So this is the Halton sequence. Then we're just going to have a constructor which is just called bool generate Halton sequence. So the thing is that we actually want to apply TXAA. I think you do apply it to the entire render target, don't you? So we want to apply it. If we go to the game menus, do our pause menu tick. We want to do canvas, add post-processing effect, FXAA post-process. So that post-process, it'll do the transform of the menu, and then it'll FXAA it. Half of the software and games dev categories are Unity projects. Oh yeah, nice one, thanks. Yeah, I've experimented with Unity, but I've not really used it for anything decent, you know. Yeah, this is a good... Try and do a lot of games tech on this stream. So yeah, I'll show you the engine. I haven't really had it up much today. Get to build first. So this would be the game. And it's just tests. It's just like a bunch of tests at the moment. There is a bunch of gameplay for a game as well, but I'm doing menus now. So I spent a bit of time doing these movable icons, but there is a level editor as well. So this is like, so you can do things like set it to be the crouch. And it's got full undo redo, and do things like add some more barrels in. And then it's got stuff like column brains, but they're like node trees for AI. AIs follow these trees you see and decide what to do. It fully one off. So you could make, it's the type of engine where you could make kind of dialogue, story-driven games. I suppose 2D primarily. So you can make those. It's built for specific types of games in mind, where you can like do things that affect the game world, which change the state of the game, which change the state of the story, or whatever. So the plan would be, hopefully, to make a bunch of games with this engine, but it wouldn't be a good engine probably for like a platformers or roguelites or anything like that. It's more like walking around talking to people, going on quests, that type of game. And it's like a code heavy engine, so it's not like Unity or anything where you do everything in the editor. The editors serve specific purpose, which is like build the levels, connect things together. So like this, you make a door and you tell it where it goes to. It goes to here. It's in there somewhere. There it is. And then that door goes to there. So yeah. And then, you know, this NPC triggers this quest. It's that kind of thing. Telltale, the engines they made. Yeah. Yeah, kind of Telltale. Not 3D really, but the game that I'm making at the moment is like a gardening sci-fi game, so gardening in space. So you're on like a big space station, and then you talk to NPCs, and then they send you on quests, which could like go to different biomes. So like different, you could go to like down onto a different planet from the space station to like gather some resource or something. And then you come back and then you get different types of plants, and then you get to plant them on the space station. And the idea is that you maintain kind of the habitable area of the space station for the crew. Yeah. Okay. So we should be in here now. Should be able to generate this Halton sequence once we spawn the menu. That'll generate the Halton sequence. And what is that? No idea. So it goes generate 2.3 Halton sequence 8. So we'll just copy this over. Oops. My neck. Like a Ferrari gone past. Array Vec 2. So this is the Halton sequence generate 2.3 Halton sequence 8 apparently. I'm just going to rename these because I don't use. That other project was an experimentation in doing this, you know, the snake case. I don't really like. Generate Halton 2.3 sequence. So this was in the maths library before. I'll keep it here for now. So we should end up with a bunch of numbers. 8 numbers. So I think the way that TXAA works, or FXAA, is it FXAA or TXAA? What am I actually doing? TXAA, so I've called this the wrong thing. The way that TXAA works is you just jitter the render target and blend them together. So you jitterate them by this sequence. So it's really quite straightforward. From what I remember. I'm going to do this as well, not right at the beginning of the tick, so it's a bit confusing. Those processes happen at the end. Oh, what's happened there? What did I do there? Windows 11's freaking me out, man. Right, cool. So we have our sequence now. We have the Halton sequence, and we'll just do standard span Vec2 get Halton sequence. Like this. And then we have the inverse width and height, which is the screen rect width and height. So this has to, we need the we need an apply for this shit, for this vertex post processor. Apply gets called right at the end, where it can apply stuff with using the canvas that it's been drawn onto. So you do apply, because this needs the width and the height of the screen rect. That's obviously going to change if you move the screen, so it needs to get applied all the time. And apply is called once a frame. And this is where you like upload stuff to the GPU, I suppose, or put it in the buffer to be uploaded to the GPU. Okay. So we've got our Halton sequence. Now what we need is the Halton. So Halton. Don't know what that is. Don't know what a better name for that would be. So this needs to be Halton.mt. I suppose this sequence, you know, that's fine. Halton.mt, and then we want the screen width, by the looks of it, screen rect width, so it's the inverse of the screen width. So auto, so it's canvas get bounds, get client bounds, dot width height. So this is the inverse. And then we need to do this calculation. So we're basically just we're just putting it into distributing them over the screen. That's what we're doing. You could say with each in the Halton sequence. This is arg. And this is Halton. Add that. I believe. Okay. Must have had that overloaded for that project. We could just do -1 onto a vec2. Vec2 identifier not found. Oh, I've done it in the wrong place. Yeah. Looking at 2 projects. So that just makes a bunch of points on the screen. I think it's in normalized device coordinates as well, so it's between -1 and +1. I remember. No, it's in +1. It's in 0 to 1 space. Is that correct? So that makes it go from... That makes it... It's meant to be 0, 1. That makes it go from -1 to +1. So it should be centered on 0. Why is it not centered? No, the Halton. Yeah, okay, no. Yeah, it's in normalized device. Yeah. That's it. So what's G state? The DX state. Where does this happen? When we create the window. Alright. So it depends where the halter needs to go now. So we're going through each of them. So we need the index. All right. So we're going through each of them. And then we're saying that is the jitter. And then we are modifying the projection matrix. Right, okay, good. That's what we need to do. I'm going to go for a 2-minute break, make a cup of tea, and we'll come back and we'll do that. Yeah, I'm back. So we basically, I think, build up a list of rendered targets, what do you call them? Render targets, each with a different jitter on it, and there must be one for each of the Haltons. TXAA history 2. Oh, it just keeps 2. Just us 2. Alright. So we also need then we need it to persist over multiple frames. So how do you want to do this? Well, we can write the DX12 post process for it. TXAA post process. She's going to be very similar to this one. So there's no transform in there yet. So in theory now, we will be going through this. Oops. This post-process now, we will be doing this. We are actually drawing stuff. Except these need to get modified by that jitter. So we've got the Halton. So it's we'll just do it like this for now. Static size t, Halton index 0, Halton index. We'll do this. We'll go the jitter is equal to the effect get Halton, really get jitter. And this is the Halton. So we'll go BM assert. Well, we don't need to do that. We'll go Halton index mod Halton count. Like that. This is the effect get jitter Alton index plus plus, and then this plus jitter.x plus jitter.y. So they're essentially shaking the screen, kind of. Mod, and mod. Oh, this is just a vec2 as well. We'll just see what this looks like. Right, it's shaking. You can see that. It's shaking. That's the beginnings of this. That also means actually when we do sample, so in the post-processing shader, where we're actually sampling here, this can go back to being point sampled because we're going to anti-alias it ourselves. So it'll look worse for the time being. It needs to be linear. Can't see the shake anymore because it's just so subpixel. Take that back, maybe it does need to actually be linear. Yeah, I think it does need to actually be linear. Right. So now we need somehow to get some. We need some state for this. So we need to store it really in the post processor. Something in the post processor. So we need have the canvas. So we need to store it in the canvas, really. So can I say with DST target never grows old? So that basically means the canvas keeps hold of it all the time. So DX12 canvas, have more. We should have stuff in here. We have rendered. So here we go. We're going to have them here. So we're going to have DX12 render target key TXAA target like that. It's going to be null. These can all be 0. Get into the habit of initializing your member variables. Okay, so we need to get the canvas. So auto canvas is pp draw context. So we need like get draw context, which it doesn't have. It does need draw context. Get draw context. Get draw context. Get canvas. And say if p canvas so we'll do get TXAA targets. And TXAA targets. These const as well, probably. It's not const. Compiler's very clever. So now here we can go auto T0 T1 equals pcanvas get TXAA targets. Let's say if T0 is null pointer, make it make it as well. And then we could probably do the actual index here as well. Size T, TXAA, TXA target index. And then we're going to have size T, next T TXAA target index, which returns TXAA target index plus plus. So this goes here. And the Halton index is pcanvas get next TXTA target index. Okay. And this, whichever one we want to bind, the desk target is equal to, I believe, so if you do, so you want the target index, is equal to target index and 1 we'll do PPT 0 else PPT 1. Just keep flipping them. Right. So now we need to do the magic bit. Just blend them. So we do resolve TXAA. So this thing called the velocity render target. What's the velocity render target? So we managed to do the first pass to gather some velocities. I'm thinking. We get the velocities. Draw velocity pass. So we need a render target for the velocities as well. model velocity. So game model velocity PS. Game model velocity VS. So it's the difference between two frames. View projection velocity. Ah, right. Okay. Sample the velocity. Sample the history. Clip the history. Sample the current. History is the one before. Oh my god. Yeah, this stops the whole thing just blurring, I think. So we need a velocity buffer. It should be more straightforward than this. So does it just have one velocity buffer? Velocity pass. So it's just the difference in pixels between two places. So go to post-processing, and then we'll have what do we want? We want blit velocity buffer. We need 8 vertices now. Or is it just we know we should blit? Yeah, we need 8 vertices. Or are we just passing the 4 differences? Not sure. That must be the model matrix. That must be the world matrix. P0, P1. So it is just a distance. I wonder if I need to do this. Do I actually need to do this on the GPU? Because we just need to record the previous values of this. Take the difference. So it would be like static previous versions. It's a standard array. Right. It's not like that. Okay, so we have our previous ones. So the difference is well, it's 4. So we want the diffs. So that essentially is the velocity buffer. So what I don't understand is what we're doing it for every single pixel. Position by the transform. The position by matrix M0 and then by the viewport. So what's the M0 in this situation? G-engine world, the world. So what is world? What is G-engine world? Just a world matrix. So what are we doing here then? And then transforming it into, so we're doing the position by the transform. So that's object space, then world space, then view projection space. So I wonder actually, to make this actually work, so we have to sample this. So these diffs could just get uploaded. So what it wants to do is splat them across the entire texture, which we could do. Just see what these diffs end up being. Tiny amounts, but they're all the same exactly. So let's just, can we do standard print diffs? Standard print line. Didn't know how to do that. How do you do that? You can't just do that. Doesn't know how to print a VEC4, that's why. Okay, no problem, no problem. Do it the old school way. So I'm gonna go beam assert diff 0 equals, well, it won't be exactly the same. See, we can make an optimization because the velocity of every pixel is the same. Because we're not moving anything relative to the TXAA. Okay. So we're going to make TXAA resolve. TXAA resolve. Don't know what to call it really. I'm going to call it Blit TXAA resolve. And this has another root signature in it because we need more root constants. We need 2 more. The velocity as well. Like that. Redefinition of verts. TXAA verts. Then TXAA velocity. Right. So I'll go do that, and then we want to go PP find root constants 1, 2, diffs 0 dot e, block offset 16. That's it. And this is not blit with verts anymore. This is blit TXAA resolve. I might do VSAA TXAA, VS main TXAA resolve as well. Different vertex shader. Don't know if you need to do that. Don't know if it happens in the pixel shader or the vertex shader. So the root constants, I think, have to be visible in everything. Visibility all, is it? Okay. Nope, didn't work. No vertex shader specified. Oh, right, okay. It is just VS main with verts. Didn't complain. So let's just check. We are going through this one and one. Yeah, there we go. So we have the velocity now. So let's just return TX float 4 TXAA velocity 0, 1. Should be practically 0. Be like 100 times that. Maybe we're going to sample it by. I don't know if this velocity thing is right. We might have to. Because this is just, it's the texture is. There should be a black border that's not there. Okay. So I don't think that's quite right. I think we have to go through velocity. which means we need to do this 2 times. I think that's what that means. Oh my god. We'll keep going, we'll keep going. So TXA8 resolve. So it samples the history. So this is quite a mental shader, this. Yeah, we need to get the velocity thing sorted out. What we need to do is render this 2 times. Well, no, we need to maintain the velocity here. Build the velocity buffer up here. So we need like 2 transforms essentially. So it's not actually I don't think it's actually the jittered velocity. It's not what this is saying. This is just the velocity of the scene. Yeah, okay. So we need to maintain a velocity buffer really. So all that requires is maintaining the previous transform. So we could do this. We could put them both in there. The transform and the previous transform. We could have like transform like this. It requires a transform. This, need to work out the transform. that. And then here we'll go get TXA transform. TXA transform. So get TXA transform. Like this. And then we need to draw the velocity buffer now. So TXA, so the previous transform equals P canvas get TXA transform. And then we basically need to do this. So this is really very much turning into a menu processor now, because we need the velocity. We need to build up the velocity. I'm going to change this to TXA canvas post process. So it very much is with just TXA in the canvas. It won't work for any kind of anything else really now. So we need to do this. And we need to do the canvas. So we need basically 8 of them. Now, and it's that twice really. And then we want the transform. And the previous transform. Like this. And then we want to do velocity. So the post processing. Ooh, Dragon, how's it going? Hope you're alright today. So we got TXAA. So it's the same as this. It's basically the same as this one. Apart from we got 32. And then this is velocity. Vertices. And then, so we got current verts. Previous verts. Yeah, I'm doing alright. It's going kind of slow, but it's because it's kind of hard what I'm doing, I think. I'll show you. It won't build at the moment or run, I don't think. So I'm working on game menus. So I put in this blur. And now I'm working on... Oh, it crashed. It's a bit buggy because I'm halfway through. And this looks a bit weird because I'm working on it. But you can like transform the menu. And the idea is like have the menu sit back, and then when the mouse comes over it, it like stands to attention, like, and then you can select stuff from it, and then when you go away from it, it kind of just goes back a bit. It's only going to be a real subtle effect, but it's going to be like it's in 3D, you know. I'll show you how. So one of the reasons why it's really wobbly is because I'm writing some... when this moves, it's going to have to anti-alias to stop it looking rubbish. So you can see there's aliasing down there. So I'm just writing some temporal anti-aliasing stuff at the moment. Yeah, it should look mint, like it should look really good when it's done, when the effect, because I can diffract the light from the behind it through it as well. So when it does this, all the light will ripple through it and stuff. It'll look really good eventually, but it's going to take a while. Take a few days, probably. So I'm doing their temporal anti-aliasing stuff at the moment. So blip velocity. And this is blit velocity. So it needs to be anti-aliased because even when it just sits there, the edges are all jagged. So VS main velocity and blit velocity. Okay, I hope you're having a good day. See if you can understand this. Oh god, let's have a look. Wow, look at that. That's nice. That's a nice blur. I've been looking at blurs for the last 2 days, so it's like, oh yeah, that's a nice blur. Using syscalls to bypass userland EDR hooks. No, I don't know what it is now, unfortunately. Is this what you're working on? What you're looking at? Wow, this looks cool though. Looks very low level. Blit velocity. Right. So the effect we want map 4x4 get transform. Called Hell's Gate, yeah, man. Okay. So this is just jitter XYUV. Apparently there's a Heaven's Gate, yeah. What did we change the name of this or something? It's called Canvas Post-Process now. Super King, how's it going? Have a look at that link in a second, Root Dragon. Get this building. Heaven's hooking Heaven's Gate. Wow. Cool reading, cool reading. Been better. Job's going okay. Oh yeah. Time has been miserable weather-wise, yeah. Where do you live? Alright, cool. So now we've got this and we want to do a velocity. I'm going to move all these down here. So this is Blit velocity. And we're actually doing this, we're doing binding two sets of, well, binding all of the root constants. So it's 32. Boston area, not the US Boston, not the UK. Yeah. Yes, you get a lot of snow up there, do you? I assume. Yeah, where I'm from, it never snows really. Although it did snow a couple of weeks ago for a day, which was nice for a morning. The thing about England is it's not warm, but it's not cold either. Tried going down the Syscall route. Ah, yeah, okay, Root Dragon. Python script called SysWhispers 2. Yeah, that's awesome. So this is a different desk target. So this is going to be called the velocity target. So the format doesn't actually need to be, it just needs to be an easy format. E-texture format. R30, R8. Should probably be R32, shouldn't it? If it's going to store velocities. No, RG16. RG32. RG16. $16 bits each, maybe. Primarily used for malware evasion. Oh wow, cool. Yeah, nice one, Moot Dragon. Right. And then we need to attach, we're going to have to attach the velocity target down here somewhere. So what we're going to do is we need to make a blip velocity pipeline. BS main velocity, I think it's called, and then blip velocity. Now this is probably not going to work because we need a specific one of these things, pipeline state descriptions. So we want full screen blit RG16. So this is R16, G16. I'm studying for anti-cheat, not making the next malware Trojan. Yeah. Awesome. Okay, so in the post processor now, and we're going to blip velocity. I'm going to blit. We need to make sure. So it returns a 2, float 2. We'll just return RG at the moment. And we'll put a breakpoint there. Check we don't get any DirectX complaints. We did. Pipeline state float. Render target format is unorm. Right, so it needs to be float. Right. Unorm is fine. Did I put float in the pipeline? Yeah. I think it's fine. Well, it's velocities though, so it could be negative. I think it does actually have to be float. So this is actually called F. Gets you so deep. Watch anything later. Never impossible. Yeah, man. Okay. So we need a new texture format. RG16F. Right, cool. So yeah, I just want to check that DirectX doesn't complain. You need to verify that that velocity thing's working. Oh, some problem there. I'm just going to delete data. I'm going to run this, and then I'm going to take a 2-minute break so I can use the loo, and I'll just run 30-second ad, but I won't be here. I'll be back in 2 minutes. Fu Manchu's back. He's back, he's back. Okay. Didn't complain. Does complain massively, actually. Oops. Oh, we're not calling reset. That's probably... We need to do a reset. Right. It's so sad, oh man. Yeah. It will be good. It'll be good for you, though. For sure. Pushing vibe. So they've been doing it. Wow. Madness. That's madness. That's madness, man. Okay, so it's not complaining. No C++. Wow. I think you're doing the right thing, Fu Manchu. Getting there with the menu. It looks pretty awful. It's shaking. It's like nervous. The menu is actually nervous. Because it's so scared of what's happening. What's being done to it. Yeah, it's not good, is it? Not good at all. Right, so we need to verify this. Working on their own branches, but it feels like a matter of time. Yeah. Putting stuff into DevMint. Yeah, man. Oh, man. Okay, so what I want to do is bind the velocity target as well. Bind target. Velocity target. And then in the shader, we just need, so what we're in TXEA resolve. Need another one. Can I just do this? I think I can just do that. No. Sure, I can just do that. The SDA API is intentionally single-threaded for simplicity and to have a clear contract of what's been allowed and not. One of those items at the SDK is thread safe, and I can see all the commits. They've tried to make it thread safe even though there's only one thread ever going to run. Is that what you're saying? What? Alright, so there's a problem. There's a problem here. I'm sure I could do that. No, not two targets. No. It's not a target, it's a shader resource. There we go. I was using atomics. But you won't be able to vibe put up this stuff, even if it seems to be working. Yeah, crazy, eh? Crazy. Okay, now it's not complaining. So what I'm going to do is I just want to look at this velocity buffer. Which is going to sample 1. That's the velocity buffer. So UV or result.uv.zw is, do we need we need current, so that's current verts to start with. current verts id xy minus prev verts id xy. Seems crazy, Fu Manchu. Seems crazy to me. And then this is keep writing auto. Float to v is input.uv zw return v. Right. Is it as straightforward as that? Doubt it. Oh, we got a crash as well, so we keep crashing for some reason. Yeah, man. Change is not always easy. So that's not quite the velocity, is it? We're obviously not updating the previous transform or whatever it is. So the previous transform got to equal to the effect get transform. Put that to 0. We can see, like, if I do this really fast, it should just go. What's this gonna do? It goes red because we're going. The pixels are going really quickly because it's a velocity buffer, and then green being the Y. So what we need to do then to see this better is when we're actually looking at the velocity. So this is float 2. And we want to return float 4, a half times colour plus a half, 0, 1. I can see it. I think that's working. Whether they're in the right direction, I'm not sure. I think they are in the right direction. Let's not do that. And then let's not update that. We can just see. Let's put that to 0. So this is moving up. Well, I don't know really which way around the Y is meant to be. Assume, well, let's put that to 0, right? Let's put the scale to 1. So let's do this, and then go to the post-processing and just have a quick look now. So this is moved down, this is moved up. It's moved down, so this would be actually a negative number in here. So it depends if up is actually up the screen in world space. I think it goes like -1 to +1, -1 to +1, doesn't it? So let's look at normalized device coordinates. Yeah. Right, cool. I'm happy with that. So we've got our velocities now. Do this. So now we need to do the resolve, the proper resolve. We've got sample velocity, which is a beast. Copy and paste that bad boy. I'm not gonna worry about that. So this is sampling velocity here. So this text2 here. Ooh, there's sampling 2 different textures. Maybe we can't do that yet. So it's point sampling. This is just G sampler. What's G sampler? Linear sampler. So let's do another one. Point sampler. G sampler. Common. So let's put it in here. Okay, so this sum point is the point sampler. UV, so that's this. Float to velocity is sample velocity. Sample velocity. Problem is that this uses 2 textures. So what's the other texture? That is the question. Texture 3. It's like a single. Is it the depth? It's the depth. Okay. Mindy. So it's sampling at the lowest depth. There's no depth in this, so hopefully we can just ignore that. Well, this just actually resolves, because if there's no depth, it's just zeros it. It's just a 0 one. So there is no sample velocity. Right. Clip history. Night child, good afternoon. You alright? RGB to that color space. Okay. Text. So this is so we just need this function. Hope you're doing alright, Night Child. Then we need to go back again. Interestingly, these don't do anything. Okay. Doing great. Vulkan Renderer. Very basic games now. Benjin 5's doing alright. I'm just working on menus. See if I can get it in a position where it's working. This is the G point sampler. Coding menus, yeah. Not doing the actual laborious bit. I'm actually doing the graphics of it, so it's actually okay. Although I think you're probably not going to be able to. Hang on, let's see. See what I'm doing because of these shaders. Give me 1 sec. Okay. Fu Manchu. So I'm doing. So I'll put this blur in. I've got a crash. I've got an awful crash. I need to figure out. That's just appeared today, as is always the case. And then I'm doing menus. So the menus in the game are gonna like sit in the background, and then when you mouse over them, they'll just like stand to attention. It'll be kind of a really subtle move, but as you just come into it, they'll just go bit. So what I'm doing is putting anti-aliasing on the menus. I've put in some stuff where you can like move. You know, you can just transform it. So I could have it set at some transform and then clear the transform over time really quickly. So it like just moves to position. That's what I've been doing. Got 10 minutes. 10 minutes to do this. I don't know if we'll get there. And then I've got some DirectX crash now from doing all this. So I need to figure that out. I think that'll be okay. So we sample the velocity. Let me sample the history. That, and then we clip it, and then we get the current. So are we binding both of them? We're not. We're just binding the source target. So, need to figure this out. Oh man, too tired for all this now. So we need to actually bind here and here. So we're going to go bool new effect. New effect is true there and there. If new effect, we bind those two. Else we bind these two. And the velocity. No, I don't think so. I don't think that's right. The current. So we're just flipping it so that it actually is just source and desk target. So it's source and source there. Source and desk target. So that's the history. Not sure about that. It'll take me probably tomorrow to get this to work. So we need three of them. And it's going to be, the velocity is number 2. History is number 1. The current point sampling number 0. Flip history. Right. Got some errors there. Okay. Let's try and get this running before I have to go with no errors, even though we don't see in the right actual We're binding the target. Okay, no. So the target and the resource. That's the source target. Source. Let's see the source. I can't do source. Source. Not source. Source target. I don't care really. Binding the target and the shader resource the same thing. Okay. So they should be opposites. No, didn't like that. So that is fine. And they're the same blooming thing. They're the same blooming thing, mate. And he's out of time. Driving music. Obviously, I've got my maths wrong. No, that's not what I wanted to do. Do that. Just getting it to run without DirectX complaining would be nice. So it's DFO 970, DFO 970. Alright, cool. Still missing a step out. I'm not sure which one it is though. But I'm out of time. Well, I've got 10 minutes. Probably got about 10 minutes. I really wanted to push this. So we're doing this jitter in the wrong place. I think we have to render to the source target with the jitter. Mad Flash, thanks for the follow. Got any questions, just ask. No problem. Fortunately, it caught me right at the end of the stream. So I want yo, how's it going? Call this Split TXAA. So we need a new shader. And then I think this is the thing that gets jittered. So we want to bind the source target. And then we want to find the shader resource, which is the source. Then we want to flush to descriptor table 0. And then we want to bind the jitter. I'm going to draw. We want to reset. See you guys tomorrow. Yeah, I'm finishing. Yeah, finishing in 5 minutes. That is where we want to do the jitter. And then we don't want to do that. I think that's what that is. I think that's it. Except we've got no shader called BitTX here, which I'll have to do tomorrow because I'm going to have to go. Yeah. Alright, that was good. Did a lot today. My brain is fried. Graphics programming is turns out complicated. But awesome. Thanks for the follows anyway. Should we run it and see what happens? It's going to fail because there's no shader. I can show you it before it fails. As soon as I open the menu, it's going to crash. And on that terrible note, be back tomorrow anyway to finish this off. We should have real smooth menu movement by the end of tomorrow. All anti-aliased and lovely. That'll be nice. Right. Thanks very much. See everybody, hopefully, tomorrow. Or online somewhere. See you later.